And
Hey, hello, Benjamin from the Eclipse Foundation. Welcome to this first webinar, this first virtual meetup. We're having a series of 9, I think, hangouts around IoT and around the Eclipse IoT project that we have. So today we're starting the series with a talk about building IoT gateways by Andrea Seiner from Eurotech. And before we start, I wanted to let you know that if you are actually watching from Google Hangouts, and I hope you are, or that's basically the same if you are on YouTube, you can ask questions right from the user interface, and we will make sure to try to answer them at the end of the session. You can also use Twitter, #virtualIoT, if you'd like to ask questions via Twitter. And for those who are attending right now, we will ask a question at the end to you guys, so as you can win a nice IoT developer kit. We are basically working on a nice demonstrator of all the Eclipse IoT technologies in action. And yeah, basically, we will have a question for you at the end. You email the answer to the question to iot@eclipse.org, and hopefully you win a nice developer kit. So without further ado, Andrea, welcome, and we are all ears to hear about Kura and how people can use open source technologies to build IoT gateways.
okay, thank you for the space you're giving me, and thank you for the people listening to us. I will share my screen now so that we can start the presentation. Okay, I think now you should see the title of the presentation.
Perfect.
Okay, great. So let's start. So the title of this webinar is Reducing the Distance Between Embedded and Enterprise Technologies. The first question is, why do we have to reduce such a distance? Well, I don't know if you all are aware about the meaning of the hype cycle by Gartners. Gartners is an important analyst, and they used to look at the market in terms of new technologies according to this curve that tells when you have a brand new technology, then you have this innovation trigger, a lot of startups, companies, and a lot of press release and marketing initiatives, and create a great expectation. And when you get to the top of the expectation, then they have seen in the last years, in the last 2 decades, that these new technologies were then not starting their roses time with their profits, but they were instead falling down into what they call the trough of disillusionment. That means very many of those startups and companies and projects fail, bankrupts, because they do not get orders. So they have the technology, but they do not have orders. And they realized that this was not a bubble effect, like it was in the internet, in the bubble of internet, but finally it was not a bubble, because finally we have had the wave of social media and Web 2.0 that became a real fact and the real market, moving a lot of money around the world. And so they see that there is this curve, then they call the slope of alignment, until it reaches a level of sustainability that they call the plateau of productivity, where companies do really start making profits. And here there is the real market. So the interesting thing is that look at the 3 things that I have marked in red: the Internet of Things, the machine-to-machine communication, and the cloud computing. So these are 3 things that are tightly connected. And you see that Gartner expects cloud computing to reach the plateau of productivity in the next 2 to 5 years in Azure, while the machine-to-machine and the Internet of Things new technologies are expected to reach this their roses in a period that goes from 5 to 10 years. So this means that it is time to start thinking to really reduce the gap between enterprise and embedded. Why? Because the analysts expect it, and I think they are definitely right, they expect the IoT to be an industrial revolution, a new internet area. And they expect it because they simply count. They count the devices which are connected, and they see how the speed that this number of connected devices takes to increase. And they see, wow, we counted 2 years ago and we expected much less, and then now they are more. And so they do the forecast and the prediction. By 2020, I didn't write a number, a figure, because I've seen that there are different figures, but finally the size is huge. So they expect to have dozens of billions of connected devices by year 2020. And M2M isn't something novel. It is definitely not something new, but it is out there since decades, but everything was proprietary. And now that we can have the machine-to-machine communication via internet and via cloud platforms, everything becomes more standard, easier and cheaper. And field data, data retrieved from sensors on the field, have always been a very good food for business applications, but it was much too an expensive food to be bought, to be eaten. So when we have the data from the sensors going device to device in a machine-to-machine application, and then this sensor going automatically into a business application, into a vertical business application, then we can say that we have an Internet of Things application. And when we speak about business applications, then we are in the enterprise business. And these software applications are enterprise software, and they are developed with enterprise technologies and with enterprise architectures, which are different from the standard and traditional embedded applications and embedded technologies and embedded architectures. But we see today that Java is the most used programming language for enterprise applications. There are more than 9 million Java developers out there. That is absolutely the largest ever community of software programmers. And there are 3 million of Java devices running embedded applications now. And a few years ago, they were counted 1/3, so 1 million. So this is increasing very rapidly. And tomorrow, when we will see that the embedded application communicate with the enterprise applications, and through a new kind of applications that we call the IoT applications, then we can count on a very large community of programmers that are the 9+ million Java developers out there. So we expect part of these programmers starting programming M2M and IoT without having the skills on the low level of embedded application problems and the characteristics. So I would say that IoT spontaneously closes the gap, or pushes the closure of the gap between embedded and enterprise software platforms. And we today still see that we are using the same language to write an enterprise application as well as to write an embedded application, that is Java. We use the same IDE, the same development environment, that is Eclipse. We use the same reference architecture. We use to decouple all layers of the software architecture, so not anymore a monolithic architecture. We use the same standards, open standards, and protocols like OSGi, JSON, REST APIs, and very many others. We use the same tools, and this is an interesting stuff that we see that it is not new in the enterprise world to have application builders, application studios, designing the screens, designing the workflows, designing the business logic, and then generating the web application, the internet application. And now we see emerging also in the embedded space the development of tools like this. So tools that permit a developer to create an application in a short time with a very limited space for source coding. That means higher usability. And then we see that we are using the same middleware, so the same brokers, the same containers, the same web servers, etc., etc. But still, even if we have these important building blocks in common, still there are obstacles to move, to permit to a big part of those 9 million Java developers used to develop enterprise applications to start developing effectively and rapidly embedded applications for their companies. So they have an IoT need and they say, how can I do it? So, and today still there is a barrier to close the gap, and the barrier is a cultural one. You have the embedded software programmers that ignore the complexity of the enterprise applications and the complexity of the enterprise architectures. And then you have the enterprise software programmers, which ignore the complexity of the embedded applications and of the M2M communication. So a typical business issue is that you start developing an M2M application or an IoT application because you have a specific sensor that you want to access mediated by a specific gateway. Then you write the application. But then after you do more software applications like that, then you realize that a single gateway is connecting more sensors with different protocols, and with different connectivity options, so radio protocols, Wi-Fi, cellular, cable, with more than one kind of vertical market business applications that have also different business models behind, and then with customer-specific business logic cabled into the source code. And this brings finally to a scenario like this, that is the point-to-point spaghetti-style interfaces, that when you have more than 3, 4, 5 point-to-point interfaces, becomes nearly impossible to be maintained. The point of failure in an architecture, in a machine-to-machine communication, are very many. And if we imagine these point of failures in a picture of that kind with a spaghetti-style point-to-point interface, then it really becomes nearly impossible to find where an error is, looking at very many different log files in very many different places. Because the communication can get broken either on the field between the communication, for instance, a radio communication from a sensor to a gateway and towards an actuator, but the communication can fail also between the gateway and the server platform, and it can fail inside the server platform. There are very many different software layers inside the platform that can crash, for instance, and then you don't know where is your message. And then there is the possibility that the communication between the server platform and the business application gets down, or simply that the web interface changed. So the payload is not anymore respected because the business application has been changed, the new release has been delivered, and is not anymore able to communicate correctly with the service at point 6 here in this picture. And then it can also happen that something gets broken into the processing at the business application side of that message. So the answer to solve this kind of problem is to make it simple. That doesn't mean to make it stupid at all, because all this complexity has a real reason, has a real motivation to be there. But we have to make it simple. And to make it simple, we have three main leverages that we can use. We have to normalize the communication, so to get rid of the spaghetti-style point-to-point interfaces. We have to encapsulate the complexity, and we have to decouple the architectural layers. So to normalize the communication, we don't have to invent the wheel. We have to look at what happened in the last decades in the enterprise software world, where we have seen the normalization done through the enterprise service bus. And then if we look at the picture of what is today a modern M2M integration platform, finally it is an enterprise service bus with different protocols. I mean, these are like MQTT. These are specific protocols to communicate with the gateways or with the smart sensors, with the devices. But it is finally a real enterprise service bus. And in the communication from the field to the business application, we see that once we collect the data from the multi-service gateway, then we have to integrate, act, store, connect, and control this communication. And this is not done by the gateway, so on the field. This is done by the server platform. And when we say that we have to encapsulate the complexity, it means that we must be able to make the entire complex communication that we have seen here in this picture hidden behind a very simple REST API interface. So just a URL with few parameters, and you have the entire communications encapsulated inside this interface. And this makes the life of a programmer very much easy. Now, let's come to the Kura scope and the Kura meaning. So Kura is the open source Java and OSGi-based application framework for embedded applications running on M2M service gateways in the Eclipse IoT working group. Its purpose is mainly to simplify the design, development, deployment, and remote management of embedded application running on these gateways or running inside a smart sensor. And Kura mainly provides a cohesive and integrated application environment, a modular software components where everything is decoupled and manageable separately, a hardware abstraction layer, which is fundamental. That is really one of the most important things because abstracts the application from the physical characteristic of the hardware. Then you have the field protocol libraries, the cloud connectivity, the remote application, the remote device management, the local application and device management, built-in security, development tools. And you see that you can have industrial hardware as well as open hardware like Raspberry Pi and BeagleBone Black. There are two typical scenarios in the architecture of a M2M multi-service gateway. Here, the green part here in this picture. Either you have a gateway that is embedded into a device, and then we call it a smart device, or you have a low-cost hardware that is physically separated from the gateway, and then the scenario normally sees the gateway as a hub, concentrated the direct communication, wired or wireless, with very many low-cost sensors on the field. But then still you can transform this simple devices into smart devices by embedding into the gateway the intelligence that is given by Kura. So Kura finally is either the intelligence of a smart sensor or the intelligence of a smart gateway that communicates with simple sensors and make the communication with a cloud platform possible, and which normalizes the communication with the business applications, that is the big IoT space. Finally, there is a third scenario where you don't have anything smart, you just have a simple hardware with a cloud client, so an MQTT client communicating directly with a cloud platform and also sending data to business application. This still is an IoT application, but very limited compared to the former two scenarios, because you will never have the possibility to remote control and remote manage this device. So it is more one-way communication, while here in the smart sensor in the gateway you have a two-way communication that is a complex communication, can be a very intelligent communication. So by the principle of making it simple, we said we have to encapsulate the complexity. That means that you focus nearly on the top of this architecture. So if you don't have a framework like Kura, then you have to take care, you have to write the source code for everything, starting from the operative system above. Then by using Java helps, because at least you can port it upon different operative systems. If you have an OSGi container, it makes your life simpler because you don't have to mind about hot deployment and stuff like that is given by the OSGi container, so the architecture made by bundle files. And then by the other layers of the framework, they free your time, and because you don't have to take care of many basic stuff that every embedded application have to cope with, but it is given for free by the platform, and we will see what are these aspects. So finally, the message is that you can focus only on the business logic of your application. So this improves your rapidity in development. That means reduce the development time, so the time to market is shorter. You can focus on your application. You can port your application on different platforms. You have a more robust code, so a higher quality in your software. You need less resources, less man hours to do the same project, the same application. So you reduce the costs of your projects. You virtualize the hardware, which is a very simple sentence here, but it is a fundamental principle. Just think about what happened with virtualization on servers. Now, for all of us, it is quite common, quite normal that when you talk about servers, you talk about virtual servers, VMware and the virtual server. So it changed completely the concept of data centers. And now, after the virtualization of servers, we have seen how fast came up the network functions virtualization. That means we were used to have a hardware box playing the role of a hub, another hardware box playing the role of a switch, of a network switch, and another one playing the role of a firewall. And now we have seen that a single hardware box can load inside the function of a firewall, as well as the function of a switch, as well as the function of a hub. So we have virtualized the network hardware, the network functions. And now that we talk about devices, by virtualizing the device, the hardware of the device, we are doing exactly the same on the 40 billion devices on field expected to be connected by 2020. So we are virtualizing the device function. That is another revolution. everything is more and more standard based, and you have the possibility to manage from remote your application. That means extending the life of your product. So Kura is designed from ground up for developers. You can have the emulator on your PC. So you start developing your application on your PC. You use Eclipse. Everything is integrated in Eclipse. Then you test your application on the emulator of the hardware. And when you are happy with it, besides if you're using Mac or Linux as operating system on your PC, then you can deploy with one click onto the real target hardware that you are supposed to deploy onto. And you can do the remote debugging from Eclipse without exiting from your development environment. And then when you are happy, you can provision via cloud. That means you can upload that application into the real device on the field with one click. And you save the history of the uploads of the software, of your embedded software into that device. And you can, of course, also roll back to the former version if you are releasing a buggy version. Another important thing is that you have the REST API integration that can, we already said, that can encapsulate the complexity of what you are developing at the device side. Actually, Kura has two distributions, one using the OSGi by Hitachi, another and the Oracle Java VM, and the Yocto WRL, and then you have an open, with an open OSGi that is the Equinox, and the open JDK as a virtual machine with any Yocto Linux, let's say. From a function architecture point of view, we said that another leverage that we have to use is decoupling the architecture, and it looks like an enterprise architecture. And while instead this is the embedded software architecture, everything is decoupled. So you see that Kura starts taking care of everything above the OSGi. So this is the full stack of a gateway, but Kura is just on top of CGI. You have the device abstraction, the abstraction layer, and then the other layers that we will see now. So you have an administration user interface that appears like this, with the widgets that you can, with the toolbar that you can, that permits you to configure the different pieces. So when you click on the device, you can configure, you can profile the device that is abstracted here. So the virtualization of the device makes it possible the profiling. You can save the profile, you can upload the profile, you can download the profile, etc., etc. Then you have the networking configuration, so linking, security, firewalling, modem, Wi-Fi, Ethernet. You can have the packaging of your update, of the software updates. And then you have a set of settings for the configuration management, for the access management, so also user and roles. You have the clock service, so you can program tasks. You can schedule. You can have you have the configuration of the client to cloud. You can configure the data service. Here, data service at this level and at this level. And then the MQTT data transportation, the position, so GPS, the geographical localization of the device, the secure socket layer, again into the transportation protocol, and then you can configure the watchdog service. And then everything is a configuration, no source coding till now. The only source coding is in your app. So you have to develop your app. So you just have to configure network, device, firewalling, etc., and to write the code of your source application. a couple of screenshots that shows you the main features, the device configuration. You can profile, you have the bundle files of your device, the threads, you have the system properties, and you can enter the command line instructions of to switch off and switch off a Wi-Fi antenna or whatever. You can configure your network, either the TCP/IP and the hardware board, moving from static or dynamic addressing, DNS, and the standard features of a network configuration. Then you can configure the MQTT transportation, switching on/off the clean session, setting the timeout, the keep alive, username and password, setting the topic. And then you have the GPS positioning configuration. So finally, Bill Gates said that he considered himself a lucky guy because he has been involved and he could contribute to something that was important. And it was important because it empowered people with software. And this quote, in my opinion, fits very well with Kura and with the open source philosophy. We can contribute to Kura. Kura can help developers creating embedded application, creating multi-service smart gateways. So you are important for Kura, and Kura needs your contribution to make it even smarter. Thank you. Now there's space for questions and answers.
Thanks, Andrea. Yeah, I really like the conclusion, actually, because what we see with IoT these days is many people playing with the hardware, but I think it's really important to, as you said, empower software developers, because there's a lot of innovation happening in the software space too, right? So we actually do have a question from Thomas, and I hope other questions will come as we start answering this one. So yes, Thomas is asking about the remote debugging feature. How much does latency affect the debugging when you do remote debugging? So can you give us some more information on that?
Yes, well, when you do debugging, I think the question rises because Thomas experienced in a production environment a problem where he had a device on the field already running an application. He didn't understand what was going wrong with that application, so he had to debug, to connect remotely into debug. Well, of course, latency when you are in a scenario like this can be a problem. But we don't have to forget that MQTT keeps the session open. The session is opened from the device, by the device, remains open. So the session should not breaks down. And I don't think that this stops you debugging, because if you have the device connected in your local area network, this is not a problem at all. I guess that he experienced this problem in a remote connection, and I would say that via MQTT delay could be a problem, but I think that you could be able to complete your debugging session without interruption.
Yeah, actually, yeah, I think most of the times the debugging is actually happening during the development phase, not really when you're in production, right? So you're actually, as you said, debugging a device that's probably sitting on your desktop, and you debug over the local area network. So in that case, I guess the latency is only induced by the speed of the target platform. And of course, if you're debugging a very constrained device with a very with very few amounts of memory and stuff, probably there will be some latency. But yeah, debugging on the field, not quite sure it's something that people really do, right? You rather, I mean, you access the logs, of course, but really doing debugging, as in Java debugging, I'm not quite sure this is something that people would do. Do we have another question? Not yet. I think I actually had a question. So I'm playing more and more with Kura, and I think you guys are planning on doing a 1.0 release in the near future. And I was curious as to what are the new features that are in the pipe, and what do you guys have in the roadmap? And maybe what Andrea, that would be great if you could stop sharing your screen, maybe, so as we can see you.
Yes. Here, Eclipse. Okay. Is it fine?
Not yet. You probably need to press the green screen sharing button. Yeah. Excellent. So what's in the roadmap for Kura?
Okay, Kura 1.0, as you said, is going to be released. Let's say it is ready to be released. I am the guilty guy because I did not yet do the announcement, let's say, but it is, yeah. And there are main features in the roadmap, and I give you also an outlook to the future release after the 1.0. So you have inside the GPIO support, so a better for general purpose input-output on the hardware is something that a couple of months ago was not there. And we have the support to the Beagle Bone Black. First, initially we only had the Raspberry Pi, so more support on the open hardware. We are increasing the number of supported appeal protocols. We had CAN bus, we had the Modbus, but we are increasing the number of field protocols. And you will see by the next year, so if 1.0 is going to be released now before Java 1, I think, so in the next days. But the next year there will be an important feature in Kura that will be the rule engine. There will be a rule engine inside the platform that will permit a software developer not to write the source code to interpret a certain threshold or to implement a certain rule conditionating the business logic of the embedded application. He will have the possibility to declare the rule in a declarative manner without coding it in Java, and this will make the programmer's life easier, and will be another step forward at the coupling architecture and reusability of business rules among different embedded applications.
Okay. So yeah, there is another question regarding MQTT. So following the answer earlier, does that mean MQTT in general is less suited to low latency communication, and would TCP byte streams be possible with Kura? Well, actually, I'm pretty sure the debugging isn't actually happening over MQTT, right? So I wouldn't be, I mean, as you described, Andrea, right, when you do MQTT, you're actually virtually connected, right? All the clients can talk with each other by interacting with a broker, and the latency is basically just the latency of the network, right? So,
yes, correct.
And second,
also have the possibility.
The question is, yeah, go ahead.
No, please complete the question.
Yeah, the other part of the question is it possible to do TCP byte stream in Kura? Well, of course, it's Java, right? So the idea is that Kura is providing lots of APIs to help you build IoT applications. So you have an abstraction of a device to cloud service to talk MQTT. And hopefully, I hope in the future there will be something like co-op as well. But if you want to use the raw underlying Java APIs to do TCP, to do FTP, whatever, it doesn't need to be in Kura. You can use virtually any Java library or Java JDK API you'd like in Kura, which is pretty nice, I think. So I think that's it with questions. Thanks a lot, Andrea. So to everybody who watched the stream, it was recorded, so you can definitely watch again on YouTube. And as I promised in the beginning, there's a question for people who were listening to the feed, and the first person to send us an email at iot@eclipse.org with the answer to the question, how many Java developers are there in the world? It doesn't need to be like super accurate, but the answer is pretty easy. If you send us the answer, you win a nice developer kit to basically build a greenhouse controlled over a Kura, over an QTT, over a co-op. So good luck to all the participants. It was really great to talk to you, Andrea. And next virtual meetup is actually next week at the exact same time. So talk to you then. Thank you.
Thank you, Benjamin. Thank you all. It was a pleasure.
Thanks, Andrea.